Is my screen visible? Okay, so I'm going for the question paper. I hope all of you have the question paper with you. So I'm going to select some questions randomly and going to solve them out. Okay. So let us select the first question that compares simple random sampling without replacement and simple random sampling with replacement and find the value of n such that variance of the sample mean in SRSWOR is exactly half of the variance of the sample mean in SRSWR of the same size. Okay. So can you tell me one thing? Suppose this is the question you have got in your, this is the question you have faced in ISS. How you are going to answer this? Am I audible? Hello? Hello, am I audible? Can anyone please confirm whether I am audible or not? Okay, so can you please try this out? That how to start this question that compares simple random sampling without replacement and with replacement? First, for this question, we are going to, if you can see the question, so there is a small portion over here. Yes, if you can see the question, there is a small portion over here which says the to compare the simple random sampling without replacement and with replacement. This is one portion, and find the value of n such that the variance of SRSWR and SRSWOR under the same sample size, one is the half of the other. So we can divide this portion into two parts. So first part we are going to answer this question, what is SRSWR? So SRSWR is nothing but, first we are going to define simple random sampling. It is with replacement. Simple random sampling with replacement. That means what? You need to define that in words, that suppose like we have capital N, the total population size, out of which we are selecting a sample size of small n randomly. This word is very important. We are selecting a sample of size small n randomly. Now what we are doing with, now this comes the portion that simple random sampling, that gives you the word randomly. Now coming for the portion with replacement. Now after how we are going to get this small n values from this capital N values? We are going to suppose this u1, u2, capital UN are my population units. These are my population units. Okay, so now what we are going to do, we are going to select a sample of size small n from this capital N. So suppose I am and with replacement means like the sample size will be any one element from this population itself, but with replacement means one element is can be repeated more than one times since we are returning it back. So now we need to define what is the meaning of with replacement. That is, we are going to select one's element or one unit, rather, whatever you wish to write, one unit or element from the population randomly, and after noting it down, we are going to replace it back. Hence, for and no, write this first. So, not so, we continue the same process until a sample of size n is not selected. So, what are the features over here? For each drawing, the population size remains same, that is capital N over here. Okay. Next is the probability of selecting each unit of the population remains same for each drawing. Okay, these are the two key points for WR. Next, what we have to do, then we are going to explain with an example. Suppose we have a population P which consists of three elements 1, 2, and 3, and we would like to draw a sample of size. So here n is equals to 3. We would like to draw a sample of size 2 from this population. So if we are drawing this sample by using SRS WR, then what will be the possible cases? And so one good thing is next what we can add, repetitions are allowed, as repetitions are allowed. Only this much would be enough. Repetitions are allowed. Okay. So if we are continuing with our example, so the set of all possible samples will be what will be the set of all possible samples if I am getting the first unit at first draw and returning it back in the next draw. I may get another first unit. So 1 1 is the first choice. May get the first unit at the first draw, may get the second unit at the second draw. 1 2 is the second choice, and 1 3 is the third choice when I am getting the first unit at the first draw. Then 2 1, then 2 2, then 2 3, then 3 1, then 3 2, and then 3 3. Remember, the order of the drawing is very important over here, because we are not considering this 1 2 and 2 1 are same. We are considering that all of the things are under consideration, and even this diagonal, that is this 1 1. Remember this diagonal, that is this 1 1 2 2 3 3. These portions are always there as repetitions are allowed. This is actually covering this portion as repetition are allowed. Okay, so these are the set of all possible samples for my case, out of which we need to draw. We can have any two samples. Either we are going to have this set, or going to have this set, or going to have this set. So this is going to be the probability. So the what are the all possible? So in case here my n is actually 3 and small n is actually 2. So and the total number of, or and the number of all possible samples is equals to 9. So basically, in general, I can write general, the number of all possible samples for SRS WR is capital N to the power small n. Is it clear, everyone? Am I audible? Is it clear?
Yes, ma'am.
So you need to define all these things, and if possible, you have to explain them with a small example. Okay. Then going for the SRS WOR part, here I'm using this red color. This is simple random sampling without replacement. Okay. So the same concept, from capital N, we are going to choose small n randomly. This is my population size. This is my sample size. And suppose these are my population units. You may not define this thing. It's okay. If you don't want to mention this thing, it's okay. Units. For without replacement, we need to mention we are going to select one unit or element from the population randomly, and after that we are not replacing it back. Okay, we are not replacing it back. We continue the process until a sample of size n is selected. Okay, next what we are doing, what are the key points of over here? The key points are for each drawing, the population size decreases by 1, because first we have n units. From here we have selected 1 unit as sample. Next the remaining units are n minus 1. From here again we have 1 unit as sample, and again we are remaining with n minus 2 units, and so on. We continue the process until we get n samples. Okay, and next thing is the probability of selecting each unit does not remain same for each drawing, because it is going to get decreased. The probability is basically nothing but, suppose I have capital N elements in the population. In the first draw, I am drawing one single sample with probability 1 by n. So in the next step, if this is my step 1, so in the next step, I have basically n minus 1 population unit, and from here if I am going to draw another sample, the probability will be this. So the probability is not same. So I am continuing with the same example. Suppose I have this capital N equals to 3 and small n equals to 2. Now we are doing the same thing with SRS WOR, but whether we do it for WR or WOR, these will be the all possible samples, yes or no? If you can see, since we are getting an unit and not replacing it back, so the set of all possible samples, we won't be getting this thing, this 1 1. We won't be getting this thing, this 2 2. We won't be getting this thing, this 3 3. The same units is not being repeated, so we can't get these things. And the order is also important, because once we have obtained this 1, we can't have 1 again. So we either can have any matching with 1, either 2 or 3, the all possible matching. Since we have 3 units, so either we are going to have 2 or 3. So if I am selecting this unit 1 2 and 1 3, then obviously the corresponding units 2 1 and 3 1 will not be selected, because already it has been selected. So this is not selected, this is not selected, this is not selected, this is not selected, this is not selected. If I am selecting, say suppose 2 3, then obviously this 3 2 will not get selected, and 2 3 is selected. So basically, for n equals to 3, small n equals to 2, the number of all possible samples is equals to 3. How we are getting 3? In general, the number of all possible samples for SRSWOR is Pn. Okay? Is it okay? Now, can you tell me the expressions of the variances? Like for SRSWR, the variance of small y bar, that is the sample mean, and SRSWOR, the variance of small y bar. Can you tell me the expressions, please? Am I audible? Am I audible? Hello? Hello? Can anyone please respond and confirm?
Yes, ma'am.
So, can I have the expressions, please?
Ma'am, sigma square by n for SRSWR. WR.
Okay. And over here?
N minus n by n minus 1. Sigma
Am I
square.
right?
Yes, ma'am.
What I have written is right, right? Okay,
Yes,
now
ma'am.
what is the second part says? Find the value of n such that the variance of the sample mean of WOR is exactly half of the sample mean of WR. Okay, WOR is exactly half of WR. So, WOR is exactly half of WR. This was the basically condition. I'm just writing it because I can't access the question and this thing together. So basically variance under SRS WOR of Y bar is half of variance of Y bar under SRS WR. Am I right as per the condition? Please read the question carefully and confirm me.
Yes, ma'am.
Okay. So can I put the, let us put the expression basically. N minus n by n minus 1 into sigma square by small n is equals to half of sigma square by small n. Can you solve and tell me the value of n?
Ma'am, 2n minus 1.
Okay, now if you can see it carefully, first we need to cancel this from both sides. Is it feasible to cancel this? Yes, it's feasible, as variance is always positive. So we can cancel this out. So it will be capital N minus small n, twice of this is equals to capital N minus 1. So 2n minus 2n is equals to n minus 1. So we are getting 2n minus n is equals to 2n minus 1, that is n is equals to 2n minus 1. How you are getting this? This is the answer you said?
Yes, ma'am. I stopped at 2n minus.
Okay, so this is the value of small n because we needed the value of small n. Okay, is it okay for all? So we are done with our question number 1. Now let us choose another question. Okay. Since we are discussing sampling today, go for this question. I'm giving you 2 minutes. Can you please think and answer me? Okay, can you tell me the stratified random sampling? Do you know, all of you know stratified random sampling, I guess?
Yes, ma'am.
Okay, so we shall discuss this thing. The question says, what is stratified random sampling? So can anyone please tell me what do you mean by stratified random sampling? Or suppose, first of all, you need to make the difference. Suppose I have a population of size capital N and I need to select a sample of size small n. Okay, so I can work with simple random sampling. But what is the situation when I will not work with simple random sampling and rather we need the stratified sampling?
Heterogeneity of population.
Heterogeneity of population. So what stratification do? How it is helping you?
Grouping into similar units.
Okay, so can you define it in more specific ways? Okay, your point is heterogeneity of the population. Okay, and what stratified sampling do? It actually divides the divides the population into. Can I write homogeneous subgroups?
Yes, ma'am.
It's dividing this population into homogeneous subgroups. Okay, so what is the utility of that? How I'm going to use it? So since it's very difficult to explain the stratified random sampling like this, so these will be the key points. So we are going to explain this in a different way. What we are going to do to make it a little bit different, first we are going to consider that suppose our population has or possesses different characteristic characteristics. Possesses different heteroscedastic characteristics. So if we use SRS, then then you write like if we are using a simple random sampling, what may happen that if you are using a simple random sampling, then the sample may not possess all the characteristics of the population, and hence it will not help us not help us to estimate it will not help us to estimate the population parameter, or you can write the population and estimate the unknown characteristics of the population okay. So what basically we are going to do for that, we are going to divide the population we are going to divide the population into mm, wait, my this pen tab is not working properly, just a minute. We are going to divide the population into several homogeneous subgroups. Okay. So, like we can give an example. Suppose we want to see the result of last semester exam of college ABC. Okay, last semester exam of college ABC. So I can do this college student, this ABC college student are my population. So what I am going to do, I am going to draw a sample from over here, and basically the suppose we are dividing, since the college possesses different streams like arts, science and commerce. So I am going to divide my whole college arts, science and commerce, and going to select the sample as per that only. From arts, we are going to select a sample portion. From commerce and from science as well, we are going to select separate sample portion. Suppose the total population size is capital N, the total sample size is my small n, and subsample from arts is n1, subsample from science is n2, subsample from commerce is n3. Subsample, the population size of arts is capital N1, the population size of science is capital N2, the population size of commerce is capital N3, such that this N is nothing but equals to N1 plus N2 plus N3, and this small n is nothing but equals to small n1 plus small n2 plus small n3. And what are the characteristics? This capital N units are heteroscedastic, but this N1, N2, N3 are homogeneous. And obviously, if we are taking sample with respect to that, these are going to be homogeneous as well. This is how we have explained the stratified sampling. Next, going for this portion is solved. Define stratified random sampling method. They are asking for the method as well. So, with an example, we divided the method. We explained the method as well as sampling. Now, the problem. Sorry. Now, the problem associated with stratification. What are the problem associated with stratification? Can you please tell me? Can anyone please answer what is the main problem of this stratification? The main problem of stratification is the selection of the appropriate subgroups. The selection of the appropriate subgroups. And these subgroups are basically called strata for stratification, because if we don't select the appropriate subgroups properly, that means we are not able to reduce, we are not reducing heteroscedasticity. So selection should be in a proper manner so that this heteroscedasticity is basically removed. Okay, if heteroscedasticity is removed, then only we can use this stratified sampling, because it is wholly based on the homogeneous stratas. Okay, so basically we need to selection of this appropriate subgroups or stratas is one of the major drawback of this stratified random sampling. Okay, next we are going for our last part. Also write down the advantages of stratified random sampling. Can you tell the advantages of stratified random sampling? Anyone? Suppose my stratified random sampling, when we are using the stratified random sampling, you need to state that first the situation for using stratified random sampling. First, you need to state that first. Next, what we are going to discuss is the advantages. The main advantage is that if the same thing we are going to repeat, if my population is heterogeneous, then we need to divide them into several homogeneous subgroups. If we can't do it and apply simple random sampling directly, then there will be a loss of information. Okay, so what we can say, there will be a loss of information in one word. So in that case, what we can do, we will opt for this stratified random sampling, and stratified random sampling is nothing but using simple random sampling either with replacement or without replacement within the stratums. Okay, so this is nothing but what can I say, this this simple random sampling, either you will go for with or without replacement within the stratums, or you can say subgroups. Okay, so these are the things like stratified random sampling actually reflects the population being studied, because what we are doing is nothing but simple random sampling. This helps you with the method and procedure. It gives you that how the sample is selected, but in real life our population are not always similar. So that's why we came across simple stratified sampling, cluster sampling based on the situation, and stratified is one of the easiest one. So on that basis of that, we can use this stratified random sampling. So is there any question from this part?
Ma'am, multicollinearity problem.
Yeah, I was just about to this select this one. This since we have only 10 minutes in hand, I would like to discuss this. Now, do you know what is multicollinearity?
Yes, ma'am.
Can you just define it in your own way, whatever you know?
It's correlation between independent variables.
No, correlation is different. Multicollinearity is different. I am just explaining. Okay, just roughly first I am explaining. Okay, then I will go with the multicollinearity. If I ask you to define multicollinearity, how you are going to define it or explain? Don't give the word define, explain. Okay, ignore my handwriting. My pen tab is just not working properly, so it's getting slippery a little bit today. Okay, if I ask you to explain multicollinearity, what you are going to say? Yes, go ahead. Yes, who was asking multicollinearity? Hello, am I audible?
Yes, ma'am.
Yes, can you just define, like, what you know? You please define what is multicollinearity. Like they have
Okay,
asked to
independent
what
variables are related.
independence variable are related. Okay. Yes, I can understood. Okay, and they have asked to discuss the effect of multicollinearity by using a three-variate linear regression model. I don't know whether I will be able to finish up this question in today's class or not, but we will be starting. So, if I ask you what is multicollinearity, then you will be writing this in one line because it's a 10 marks question, including this portion. because these are broad answer type, right? What you said is absolutely correct. I am defining one thing. Okay. This is a three variate model. Am I right?
Yes, ma'am.
Okay. So, as much as I have understood, you are trying to say that if any of the independent variables, like these three, are my independent variables, and this is my dependent variables, and we call the dependent one as response, and we call the independent as covariate, right? So if you are saying if my independent variables are related, what do you mean? And first you said some word about correlation. Don't go with the word correlation. First you say if one of my if the covariates are related to each other, that means if suppose I am getting something like this, x1 is some function of x2, some function of x2. Okay, if I am getting something like that, then it is actually called my multicollinearity is presence in the data set. Because if x1 is itself a function of x2, then why would I go for x2? I should have written x1, suppose x1 is nothing but twice of x1. Oh, sorry, twice of x2. Okay, so why I will go for x1? I should have replaced this x1 with something like twice of x2. Then my model should have become beta naught plus beta 1 plus twice beta 1 plus beta 2 into x2 plus beta 3. Then what is our target in models? In models, our target is to estimate these unknown coefficients. Am I right? So here, if we are going to estimate, we have to estimate 1, 2, 3, 4. We have to estimate basically 4 coefficients. But if I am clubbing this up, we are basically estimating 1, 2, and 3 coefficients. Because if you can see, however we are trying, we will be estimating these two things together. From this portion, it's not possible to estimate beta 1 and beta 2 separately. You will be getting something like this. A total hat you will be getting, but you can't get separate beta 1 hat and separate beta 2 hat. Are you getting my point?
Yes, ma'am.
Okay, so that means it is reducing the number of coefficients that I need to be estimated, and also reducing the number of covariates as well. Like I have actually came down to 2 covariates only. So that is why what we can say, this is where the problem of multicollinearity lies. That is mainly I wanted to say this thing, like basically what we are doing is like the when my covariates are related to each other, so it's very difficult to estimate their coefficients, and these estimates are the thing which is going to help me that what is the effect of this particular covariate on my response y. Am I right? Suppose the like with that adjusted r square, with r square, with p value, and even with the value of this estimate, suppose it is positive or negative, we can judge that whether my that covariate x1, x2, or x3, how it is affecting my response y, whether they are positively related. Suppose I am getting something that y equals to 2x1 minus x3 plus suppose some 5. Okay, that means how can I arrange it? 5 plus 2x1 plus minus 1 into x3. So what is my, this is my beta naught, this is my beta 1, and this is my beta 2. So beta naught is nothing but the intercept point, but beta 1 is basically my positive. That means it is the coefficient of x1 is positive. That means if x1 is increasing, that means y is also increasing. it is positively related, that it has a positive effect on y, and but since this one is negative, so it is negative effect on y. So since these estimates are very important, if my covariates are related, it's very difficult to estimate the individual estimates with that thing. So this is where the problem of multicollinearity lies. And with the three variable models, what you have to do, you have to find the estimate and the measure of multicollinearity, which we will be discussing in our next class, I think, which is on Friday, right? No, not on Friday, which is on Thursday, I guess. Is it okay? I will be discussing this whole question, don't worry.
Okay,
Yes,
ma'am.
are you saying something? You are not audible. Anyone is saying something? You are not audible.
Nothing. Nothing.
No, except for you, someone else is saying something. Am I audible? And not only that, one more point you may add over here, that this multicollinearity okay, uh, can, if not can, basically it is in multicollinearity affects the variance of beta i's. This estimates is the expectation of this estimate, and this expectation of variance of these beta i's are also been affected with respect to this multicollinearity, because if there is a presence of multicollinearity, is if it is present in my data set, so before going for any statistical analysis, first what is our target is to remove multicollinearity. And what are the major methods of removing multicollinearity? Can you tell me what are the major methods of removing multicollinearity? Am I audible?
Don't know, ma'am.
You don't know what are the major methods of removing multicollinearity? One of the measure is PCA. Have you heard of PCA?
Yes, ma'am. Principal
PCA
component.
is one principal component analysis is one of the major method. Other than that, there are many other methods as well. But as per like the people who are learning statistics, PCA is one of the major method for removal of multicollinearity from your data set. Okay, so we are going to discuss all these things in brief, if you wish, in our next class, while we are going to deal with this particular question. Okay, since I have not completed this part of the question now, so I'm going to discuss with this question next class, and also I'm going to select some other questions from this portion randomly. Not here from this portion, like this AR model, from this autocovariance function, autocorrelation, and some from the time series, some from the index number, which are very scoring portions, some heteroscedasticity portion. This I'm going to discuss in our next class. Okay.
Okay.
Okay. So any queries from today's class, anyone? Okay, hope not. So if you have any queries, you can post your queries to Shorob's class helpline, and they will be communicating the queries to me. Okay. Thank you so much, all.